Hello friends, a warm welcome to all the Wisdom Jobs viewers. In this video, I am going to explain about what are acids, bases and salts. So this is a topic which is very much useful for the 10th class students of NCERT syllabus. Before going to the topic, I am going to request you to subscribe to our channel Wisdom Jobs for latest updates, because we are going to give you so many videos which are very knowledgeable, and if you have not subscribed it yet, you are going to miss them definitely, and they will definitely help you in the preparation of examinations. So please do subscribe to our channel, and after the video, if you have got any queries, please do express your queries in the comments box which are being provided at the bottom of the video, and as and when we get the time, we are going to answer your queries. Now let me enter into the topic. The topic is acids, bases and salts. Okay, now in your kitchen or in your rasoi, you have seen a lemon. Okay, and lemon definitely will taste sour. Okay, and if you observe one more property of this lemon, if you rub lemon on a black surface, it is going to turn into a white surface. Okay, so why it is happening? Actually, it is due to the oxidation of that particular material. So in very old days, maybe in 1600s or 1700s, they have defined an acid like this: any substance which is sour in taste, okay, is called as an acid. So any substance which is very sour in taste can be called as acid. Okay, so by taking the example of citric acid and some other organic acids like acetic acid and all, we can say that acids will be definitely sour in taste. But if you take sulfuric acid and hydrochloric acid, so if you take the concentrated versions of sulfuric acid, hydrochloric acid or nitric acid, they are not sour in taste, and moreover they are not palatable. That means we should not inhale them. So we should not consume them. So we cannot say that this definition of any sour substance can be called as an acid is incorrect. Okay, so now something else is there which is to be defined for acid. Okay, next in the same years they have defined a base as a bitter substance. Okay, all bitter substances they have categorized as bases. Okay, but if you take very hard bases like sodium hydroxide, calcium hydroxide, magnesium hydroxide, okay, so these are very strong bases. No doubt they are caustic in nature or they are bitter in taste, but these some of the bases are not bitter. So this statement of all the bases are bitter will be contradicting for some of the bases. Okay, so if you take ammonium hydroxide, so NH4OH, okay, so it has got a different taste than a bitterness. Okay, so it is pungent, so ammonium hydroxide is very pungent. Okay, so it is very inhalable. So obviously what happens, the basic definition of all the bitter substances are bases is also disproved. Now next came the ideology of hydrogen ions. Okay, now how can I define an acid now? So now any substance which can donate H plus ions, such a substance is going to be called as acid. Okay, and any substance which can donate OH minus ions. Okay, so any substance which can donate OH minus ions, or this is also called as hydroxyl ion. Okay, what is the name of this? Hydroxyl ion. Okay, so any substance which can donate hydroxyl ions is nothing but a base, and any substance which can donate H plus ions can be called as an acid. That is the other definition of our acids and bases. Now can you give, based on the new definition of acids, we can give some acids name. So sulfuric acid is H2SO4, and it has got two H plus ions that can be given. Similarly, if you take HCl, that is it has got one hydrogen ion that can be replaced. Okay, so sulfuric acid has got 2 replaceable H plus ions and HCl has got 1 replaceable H plus ions. And next is you have got acetic acid. So if you take acetic acid formula, CH3COOH. Okay, so this H which is at the end, that can be replaceable. So acetic acid has got 1 replaceable H plus ion. So in a similar way, if I talk about the bases, okay, so we have got different bases like those substances which can give away OH minus ions, those I can call it as bases. So some examples of bases include NaOH, which is sodium hydroxide, potassium hydroxide, NH4OH, which is ammonium hydroxide. Next, we can have calcium hydroxide, magnesium hydroxide, etc. Okay. Now, coming to the strongness. Okay. So whether it is concentrated or diluted. Now, the degree of dissociation and the amount of H plus ions, the number of H plus ions that are being given by a particular acid will decide whether it is a strong acid or a weak acid. Now, if you take H2SO4, that is sulfuric acid. So, when it is taken in aqueous solution, okay, when it is taken in aqueous solution, it will be 2OH plus SO4 2 minus, right? So, these two hydrogen ions can be completely liberated when you take little amount of water. So, since it is giving readily the 2 hydrogen ions present in sulfuric acid, it is a strong acid. Some more examples of strong acids are HCl, that is hydrochloric acid. Next is nitric acid. Okay, coming to weak acids, phosphoric acid, that is H3PO4. It is a weak acid, and CH3COOH. Okay. Next, it is what? Acetic acid. Next, H2C2O4. What is H2C2O4? Oxalic acid. So, these are some of the examples of weak acids. On a similar lines, if you take sodium hydroxide, NaOH, and try to electrolyze it. Okay. So, if I subject sodium hydroxide solution to electrolysis, so it will readily disintegrate into or ionize into sodium ions and OH minus ions. Okay. So, the number of OH minus ions that are being formed is very high number, great number. So, that makes me to say, or that makes me to call that sodium hydroxide is a strong base. Okay. So, some more examples of strong bases include KOH, which is potassium hydroxide. Next comes calcium hydroxide, magnesium hydroxide, etc. Okay. Magnesium hydroxide, etc. Now, coming to the weak bases, we have got ammonium hydroxide. So, NH4OH. Okay, this is a weak base. Next, we have got zinc hydroxide, which is another weak base. Okay. Next, we can say about ALOH and thrice. So, this is also a weak base. Okay. So, these are some of the examples of weak bases. Now, let me go for the next concept, which is salt. Okay. Now, what are salts? So, what are salts? Now, whenever an acid reacts with a metal, the metal displaces the hydrogen ion. So, I will give you one example so that you can easily understand. So, let me say sodium is reacting with HCl. So, the product is NaCl obviously, and hydrogen gas is liberated. Okay. So, let me balance this equation. So, if I put simply 2 here and 2 here, so 2 NaCl plus H2, and H2 is a gas which is indicated in an upward arrow. Okay. So, now let me explain you this concept actually. Take a brine solution and heat it. Okay. HCl in the test tube, take NaCl in the HCl in the test tube, and slowly dump sodium pieces. Of course, sodium pieces will be kept in kerosene. So we need to slowly dump them because sodium metal is highly reactive. Okay, so slowly dump the metal here. So what happens in this beaker or in this test tube, there is a formation of NaCl and the gas would be liberated. So the hydrogen gas would be liberated. So that would be taken out, and at the mouth of the opening we'll put a sphincter. Okay, we are going to put a sphincter which is having some flame. Now this sphincter will be put off with a pop sound. So which gas will make a pop sound? It is nothing but hydrogen gas, which indicates that whenever there is a pop sound, this pop sound indicates that the liberated gas is hydrogen gas. Okay, so we can easily say that whenever a metal reacts with an acid, so this is what actually hydrochloric acid. Okay, so whenever a metal reacts with an acid like hydrochloric acid, its respective salt would be formed. Now one more example I can give you. If I take magnesium reacting with sulfuric acid, concentrated sulfuric acid, magnesium reacting with concentrated sulfuric acid, so what is formed actually? MgSO4, that is magnesium sulfate plus hydrogen gas. Okay, so in this way the salt is formed. So the salt is formed by reacting the original metal with its acid, with any acid. Okay, so the respective acid salt would be produced with that metal when the metal is reacting with the particular acid. Okay, so in this way I can produce the salts. Now let me go to the next topic, which is called as which is nothing but reaction of two substances. One is an acid, one is a base. Okay, now let me explain you that concept actually. Coming to the next concept, which is reaction of base and acid. So when two acids and bases, when an acid and a base are reacting, so what is happening? Okay, now for this, take a test tube like this. Take a test tube and take one of the bases whichever you want. Now I am taking, let me say, milk of magnesia, that is magnesium hydroxide. Okay, which is MgOH taken twice. Okay, so in this milk of magnesia, I am going to pour slowly concentrated sulfuric acid. Okay, so now what's happening here? You can able to see the reaction. So H2SO4 plus MgOH taken twice would give you what? Would give you MgSO4, the salt, respective salt, plus, now let us balance this reaction. So OH, so how many O's are there here on both sides? So sulfate is over, magnesium also is over, right? So now O are 2 remaining and HR, here it is 2 and here it is 2. So 2 plus 2, 4. So 4H2 and 2O. So it will be giving you 2H2O. Okay. So whenever an acid and a base, preferably a strong acid and a strong base, react with each other, what is formed actually? You are going to form a respective salt and water. Okay. So whenever water is formed, that reaction we name it as neutralization. So we say that the basicity of the base is neutralized by the acidity of the acid, or acidity of the acid is neutralized by the basicity of the base, or vice versa. Okay, so any reaction in which an acid and a base are going to react to produce a salt and water, such a reaction we are going to call it as neutralization reaction. And one more advantage, or I should say one more byproduct, is heat is generated. Okay, so some amount of heat would be generated, delta H we are saying, let me say. So this is, of course, delta H is dependent on how weak or how strong the acids and bases we are going to take. Okay, so if I am going to consider, for example, this one, magnesium hydroxide is a strong base and sulfuric acid is even a strong acid. So when a strong base and strong acid are reacting, definitely there will be a possibility of effervescence, and due to this effervescence, so much of heat also is generated. So the amount of heat generated in a reaction like neutralization will be dependent on the weakness or the strongness of the acid and base you are going to take in the reaction. Okay, now after this neutralization reaction, in the next video I am going to present you about what the different topics on how to generate a base and how to generate an acid. Okay, so thank you for watching this video. If you have got any queries regarding this topic, please do express your queries or doubts in the comment boxes provided at the bottom of the video, and don't forget to subscribe to our channel wisdomjobs.com for latest updates. So we wish you all should get very good marks in the coming examinations. Thank you for watching.